A long-term memory is usually what we mean when we talk about memory. It is considered the relative permanent storage of information, or our memory bank. There are different types of memory within long-term memory. Some are explicit, some are implicit. Within explicit memory, there are two types: episodic memory or semantic memory. Episodic memory is also referred to as personal memory. It's a collection of personal events happening to yourself. This relationship was found with one very famous patient called HM. When he was 27 years of age, he underwent a surgery which aims to cure his severe epilepsy. The surgery took out a large part of his hippocampus. As a consequence, he could not form any new personal memories. Anterograde amnesia means a person's inability to form new personal memories, or more precisely, the inability to transfer information from short-term memory into long-term memory. Even though HM lived to a good age, he couldn't remember anything that happened to him after the surgery when he was 27. He often joked about his amnesia and remained mostly in a very positive mood. If you look into his medical record more precisely, you'll find that not only was his hippocampus removed, along with it, most of his amygdala. The removal of his amygdala may have contributed very much to his upbeat, positive mood. Interestingly, HM's condition also revealed to us the distinction between explicit and implicit memory. Explicit memory is also called declarative memory. That is, the memory that you can actually talk about, that you can declare. Implicit memory include procedural memory and dispositional memory. Those are the things that are hard to describe with words. For example, within implicit memory, procedural memory is also called motor memory. For example, your ability to play the piano, your ability to swim, all of these memories are procedural memory, or we call muscle memory. With HM, even though he could not form any new memories that is declarative, he could still form procedural memory. For example, at a later age, he learned how to ski. He actually skied pretty well. If you put him on a ski track, he could ski reasonably well. However, if you ask him, HM, could you ski? The answer is always negative. Even though HM has acquired his new ability to ski, a new procedural memory or implicit memory, this procedural memory or implicit memory is dissociated with his explicit or declarative memory. So when asked whether he could ski, he doesn't remember that he could ski. He couldn't declare his ability to ski, even though his muscles know how to do it. So episodic memory is related to your personal life. It's like episodes after episodes of your own personal events that's revealing what you did in your past life. Memory that are episodic include things like where did you spend your last vacation, who did you write to in your last email, or what did you have for breakfast this morning. These are related to your personal life. Episodic memory is one type of declarative memory. The other type of declarative memory is semantic memory. These are facts that you remember, things that are not related to you personally. For example, there are facts about science, about concepts, mathematics, geography. These are all semantic memory. They include things like which city is the capital of China, or things like what is 2 plus 2. To recall the answers to these events, you need to rely on your semantic memory. Both episodic and semantic memory are part of declarative memory or explicit memory. In contrast to explicit memory, there is also implicit memory. Implicit memory include procedural memory, motor memory, or dispositional memory. The motor memory part is easy to understand from the example of HM, his ability to ski, or muscle memory. The other part is more complicated, dispositional memory. Let me use one small example to illustrate the idea of dispositions. What I have here are two lists of words. On the left are scrambled words. On the right are the correct words. Your task is to unscramble these from the left to the right. This is not a very difficult task, and you can actually solve them one by one. Let's do them together. You can see the first one is rose, and then petal, stalk, stem, blossom. What is the last one? Actually, if you try to solve the last anagram puzzle by itself, it can either be unspelled as leaf or flea. But if you have been doing the other anagram task before this one, you're more likely to answer with the word leaf. This is called priming. What I tried to do with these other anagram tasks is to prepare your mind to a word that's related to the concept of rose. When this concept is activated, then you're more likely to recall a word that's related to this concept. Hence the word priming. So dispositional memory works in a similar fashion as priming. You can either be primed by a particular context, that is an environment, or you also can be primed by an internal environment, a particular mood. Let me provide you with two sets of examples. I have two examples that's related to context-dependent memory. The first example is a psychology experiment. It's an experiment about remembering list of words, a very familiar task. But this experiment's environment is rather bizarre. Half the participants learned this list of words in a normal condition, like in a classroom. We call this the ground condition. In contrast, the other half of the participants learned this list of words underwater. We call this the water condition. The interesting part of the results is about recall. Within each condition, half the participants were recalling the list of words in the same condition those words were learned. That is, water, water, or ground, ground. The other half of the participants have to recall the list of words in a different condition. That is, if they learned the task underwater, they have to recall the task when they are up in the ground, or vice versa. This following diagram shows the accuracy in terms of recall. As you can see, if the context has changed, then recall suffered most. As you can see from these two blue bars, if the context has switched, then the accuracy recall is lowest. If the context has remained the same, the accuracy is actually better than the previous conditions. The two purple ones shows precisely these two results. And unsurprisingly, the ground-ground condition is the more ecological condition, achieving the highest recall of accuracy. The water-water condition achieves the second best in terms of accuracy. But interestingly, the water-water condition has better accuracy in recall than the water-ground condition. Context-dependent memory can have its interesting applications. Usually, in terms of sport events, there is a term called home advantage. If you compare playing at home versus playing in a different field, the advantage is about 5% in terms of chances of winning. It's a small advantage, but still an important one. Knowing that there is home advantage in terms of sports events, there may be other implications of context-dependent memory in terms of other memory events. For example, if you need to prepare for an exam, where should you do the preparation? In the library, in your dormitory, or in a classroom? The home advantage probably is most significant in a classroom setting. That is most similar to the place where the actual exam may take place. These context-dependent memory are related to procedural memory. Let me tell you another very interesting episode that's related to context-dependent memory. The name of the film is called Shower, and the story is about a coal mine worker who loves singing. Usually at the end of the day, after working laboriously underground, the co-workers together would take a shower, a public shower, and he would always sing Pavarotti. His colleagues were amazed by his ability to sing, and they felt that he could actually be winning a singing contest if he was entered one. So without his knowledge, they entered him in a singing contest in their local city. And at the day of the event, his colleagues put him on a bus and they all went to attend this singing competition. Unprepared and feeling very nervous, when he was all dressed in suits and standing in front of the big audience, he lost his voice. He couldn't sing. And it was a very embarrassing moment until one of his younger colleagues thought of an amazing idea. His younger colleague understood the idea of context-dependent memory, and he knew that every time he sings Pavarotti, it was always under the shower. So in order to recreate such a context, the colleague found a water hose, and while he was embarrassingly standing at the stage, speechless and voiceless, he felt there is cold water showering him, covering his body. And from that moment, Pavarotti came out as the most beautiful voice out of his body. So you can see, if a person is used to performing a particular task within a particular context, then recreating that same context would bring out the performance more easily than if the person is put in a very different situation. The story of the film rings a bell to what I talked about in the previous psychology experiment. If you compare the recall from water-ground to water-water, water-water gives better performance, doesn't it? Our memory is not only context-dependent, that is, our accuracy recall not only rely on the external environment, but also sometimes our internal state. State-dependent memory talks about how our internal physiology determines our memory recall. This is most clearly illustrated by a case with bipolar depressive patients. Information learned in the maniac state is better recalled in the same state, and vice versa. This is, again, very similar to the water-water, ground-ground, water-ground-ground water condition. But in this case, the environment is not the external environment, but a person's internal mood.